So Danny and I here are presenting the work we've done doing the EACVA project. The work is titled Labor, and we tell about it in a short while. It was important for me to open up with this very quiet and slow video because I think we're living today in a very strong digitalized era where everything goes fast, when we are used to see results, and the process is being forgotten. And the process, when we're talking about painting, the temporality, the time of the drying of the paint, for example, that we added here in the video, with this extra fan to get the exact time when the paint is dry before another layer comes on top, the interaction between the artists and the machine, the painterly process that what it takes, the computational processes of what it takes, the decision making that are keep changing, adapting, rethinking, rewriting, all of these parts are almost being forgotten, I would say, today in both traditional painting practices as how we've been consuming them as mainly digitalized images, and as well with the expectation that we have from computer systems to create images for us. So I think, in a way, I would like in this case to refer to a lot of the earlier talk that we had with the drawing machines of Jack Tate. It's really about the time, the physicality, the mechanicality, and how that goes with how we think as human, and how those processes can bring us to new decision, to a new path of thinking, and to the new creation opportunities. And this work, Labor, was being created as a performance. So it's not only about a painting that you see is end up in a fairly large one. This is a 2 meter by 3 meters. We operate in several versions. Here in the chapel we have the third one. This was the first version that was presented in CLB in Berlin exactly 1 year ago, or a year and a half ago. Shortly about who we are, Daniel, Berio, and myself. So I'm coming from a classic painting background, but start working with robotic technology over 10 years ago, with the first collaboration with the eDavid robot that Michael presented here before, and Patrick as well was working with Professor Deussen. I was working there, you can see the old KUKA machine at the time, working with a fairly simple JavaScript and processing that I worked together with Thomas Lindemeyer that ran the machine at the time. Then there was another project done later with the ABB machine with Marvin, who was the previous PhD candidate, and Michael was actually supporting that project. There was a different project done at the Jewish Museum in Berlin with small drawing robots running around and writing on sands. Works done at ETH in Zurich, working with neuromorphic biological inspired technology for adaptive robotics for painterly processes, and so on. So I was always, for me, interested in the question of painting, how painting can be used in our contemporary technology and how that can be reflect when working with robotics. So the kind of shiftment that I had 10 years ago moved out of the interest of the mechanical operation of our body while we are painting, and how that can be used with contemporary technology. And in this case, I was thinking more of robots, of machines that has bodies, and not necessarily through digital images. And this is where those collaborations started.
Okay, I'm Daniel, and we have with Liat we have a similar way of thinking, but very different at the same time. So I come from, like, a part of my background is also from graffiti art, so like very instinctive painting with spray paint or markers and stuff. And a lot of that for me comes from motion and learning motions and assimilating them. So then I also related to what Gareth was talking about, kind of I got into a rabbit hole of technicalities, and on a journey of researching ways of how to get computer graphics system to create aesthetics that are similar, that feel familiar to my way of seeing graffiti art. It's a bit personalized, but it ended up bringing to some research things. I sometimes, as a joke, call it computer-aided graffiti design with a G. And I like machines. I like to work with plotters, robots, and things like that. And I have this obsession with working with curves that have a certain aesthetic that I try to achieve. So in this project, we kind of put together those ideas with Liat from a more painterly perspective, and me from maybe the more technical perspective of modeling these kind of curves and applying them with robotics and with material with Liat's guidance. Yeah.
So just for the history, so Daniel and I have been collaborating now for a good 5 years, I would say.
Yeah, yeah.
And as Danny said, what brought us together is when I started working with computational technology and with robotics, I very quickly got bored with the image, and I was much more interested of trying to understand what is a brushstroke. It sounds very, very banal to many of us and think, okay, it's something that starts and move and end. It's something that machine cannot understand and recognize. And for me, it's a big gap between what we do, what machine can do. And this is what Danny as well was interested as a graffiti artist. It's the body movement, it's a gestural element. So we start to look at images as lines, as vectors, as layers, as an action in time, and not as a static element that we try to reproduce or to replicate or to even create an object that can stand by itself. And this latest work that we've done for the EACVA project is called Labor. It started with an initial collaboration with Professor Inga Hermann from the Nanoparticle Engineering Lab at the ETH Zurich, where we got as well an SNF, a Swiss National Fund support for the creation of the artwork. And Inga's research is dealing with women's health and specifically about the reproduction systems. It's a apparently element there is very little knowledge about. There is very little data being collected. And she started with one of her researchers to collect images of the placentas. And she provided us with those like really beautiful nano images that we decided to use and to enlarge for our robotic painting. The word labor holds two meanings. The labor is probably here in the UK, you know, there is the Labour Party, it's the working class, it's the manual workers. It's the craftsmanship. It's the knowledge that belongs to our bodies. And this is something that in our Western society was being suppressed, being put down for many years since I would say it's kind of a jump after the Industrial Revolution, but I think it has, I'm not a theologist, but as well from religion reasons and so on, the body was always kind of put down while the mind was putting much higher. And if we're thinking of the first models and conception of robotics, of AI, of computers in the 50s, in the 60s, the first was to try to imagine as well like the mind element, but where was the body? What happening to how human system, the human physicality operates? And today we reach to a point that a lot of the intellectual tasks can be replaced or imitated by AI, by computational systems, but the machines prove themselves to be fairly stupid with everything that has to do with body. And as the workers are being marginalized, the way it's being paid and so on, this is for probably all of you and from specifically the female here knows that the women are being marginalized systematically in our society as well, and more so our bodies, that the knowledge in medicine in our bodies are actually have the highest intelligence of creating life, of bringing even the next generation. This is such an enormous level of knowledge that is barely being acknowledged. So this work kind of tried to bring these questions of what is the role of our body in the time of mechanization, of digitalization, and of simulation. If today, I can tell from my own personal experience, but I heard many women that share that going into delivery in a Western hospital, the doctors will preferably like to listen to what the machine is saying statistically, and what is like the numbers are saying, but kind of ignore what we have to say. So we want to kind of try to envision a new situation where the machine is collaborating with us in the creation of a new artwork. And we rethink this operation of the machine, we adapt to it. It's not a deterministic process, it's something that goes step by step. This is a different work of the labor that you can see that we've done with EPI in Germany. Then you want to just elaborate a bit about the process?
Okay, the process, I will go into more details in a bit, but the process essentially is taking one of those images. We selected some of the images that Inge and their lab gave us, and the idea is we subdivide the image into tiles, and because the robot's workspace is quite limited, we paint each tile separately. And the system that generates those tiles is an optimization that uses an AI-based algorithm, which I will explain after. But essentially, each tile, kind of this shows a bit the view from my side when I'm working on them. This is an example, right? You have an example image, the tile, and you have strokes that can be executed by the robot and get adapted to this style. And then you have a style guiding image. In this case, you see this is sketches similar to what we did with Anna. Those are sketches made by Liat, and we try to use that to influence the stylization of this image. And yes, that's about it. And then I will give more details later. Yeah.
And I think part of like the wish that we had with the support that we have with computational technology today is to take something that like a nano image and to enlarge it into something that is actually like bigger than us.
Yeah.
And to really get into the ability to play with every nuance, with every singular tile. So during this process, as we say, it was not a deterministic process. We painted each tile at a time. Sometimes we took it down, we redone it. We painted over that manually. We, like live at the location, always mixed the paint. It always differs if it was a warmer day, if it was a colder day, how quick the paint is being dry, the deformation of the brush. This is specifically, we worked here with acrylic, and then try to find what is the best way to layer the work. So here we worked very, I would say, systematically in layers, starting with very large strokes into very small. And trying to kind of think where we are trying to replicate or to learn from how human paint, and to think what robot can give us that human cannot in the painterly process, and to kind of compare. For example, I think one of the issues with such a very detailed image, and we work in here specifically with breaking everything into lines. We are not talking about segmenting areas into paint area. Is, for example, how do you create it without doing too much noise in the eye for the observer? And as a painter, I think as a human, we have the tendency to abstract, to reduce, to create lines that create forms, to say, okay, this is going to be quiet, this is going to put up a bit. This is like an abstraction knowledge that our brain can do, but machine cannot. Machine are actually, because they train much more on LLM systems, they need to have object, they need to have very defined areas. And here we're really going into this like gray zone of like, how can you deal it and how can you tweak it with taking what the machine can offer versus how a painter will deal with that. And then there is a lot of elements that I really enjoy to work with robotics, and specifically as well with Danny, is like how can you take something that's very articulate, something that you see like those kind of a brush strokes that seem very freely, very light. We like to call them a kishkushim, like a scrambled thing, that you keep thinking like, every child can make that, but none of us can repeat that exactly with the same precision as a machine can. So what we kind of done to create a level of even kind of an uncanniness of the aesthetics the robotic gives us is to repeat some of those strokes, but for example, just move it 0.5 millimeter to the right, give it 0.5 centimeter less of a pressure, and then suddenly you have the same motions that created the first one happening again, but with a totally different like result. And this is kind of the two last layer here, this like light greenish and the very almost like yellowish whitish. And this is just kind of a couple of close-up from the large image. So the large image has 96 tiles, I think. It's almost 100 tiles.
Yeah.
Each one of them are 35 by 35 centimeters, no, 25 by 25 centimeters, and they're produced with acrylic. And this is just a couple of the examples. You can see some areas with a bit of darkness that I came in the end just to kind of calm it down. Some of them we left, some of them we changed through the process. Another element that we would like to talk, because I know whom of you who were in the opening yesterday, they saw we worked here now not with acrylic on wooden panel, but on ink, on a calligraphic paper. And this is something that I'm playing with, and it's kind of my focus, I would say, since 2018. I kind of shifted into paperwork and ink work and calligraphic elements because I enjoy the agency of the material. So going to the beginning, when you talk about working with robotics, computational system, with another collaborator, you give away your agency as an artist. The machine has an agency, but the material has an agency as well. And if I'm kind of referring to my classical education in art academies in Germany, where I studied in Leipzig, you're kind of being taught how can you control the material into the max. And I was doing some Japanese calligraphy in my earlier years, and there it was exactly the opposite. It's about how you control your body and you respond to the material. And that I found very interesting. If you leave another level of lack of control and you give it into the materiality and you try to see how that can guide us further in the decision making of how we will program the machine to operate with the amount of, for example, if we work with a calligraphic brush, every time you dip it, it goes back into zero, I would call it. It's getting pointy. You can do a very nice lines. The second you operate a bit of more pressure, it's deformed, and then you get really funky lines that I specifically enjoy. But then the level of us to be able to predict the outcome is much less. Further, the surface is very absorbent, and it just take that in, and if it's staying wet and you go on top of it with a new layer of paint, the paint goes into different, like even if I painted here, but there was a wetness connecting all the way here, the paint that was put here was going all the way there. All of this is information that us, as human, as embodied intelligent, we are capable to respond, to change, to adapt, but machine cannot. And how can you program a machine when you have to take these elements under consideration to achieve some wishable result, I would say, in this kind of conversation?
So yes, so here we get into the other concept of labor, which is programming those things. So it's quite laborious, and those optimizations take time. So here's an example. This iteration you see here, it's been quite a stressful period. We didn't have a lot of time, so it was like, this is an example of like 2 or 3 days of nights of stuff running, and me next morning checking what the results are. And we were kind of happy with, we were starting to like the results here, but then in robotics, you call this the sim to real gap, right? So you have a simulation, it looks good, then you go with a brush and you do it, and it's like, what the hell is this? And it's brush deformation, right? So that's future work to kind of compensate for that with techniques and everything. But yes, not satisfied with the results. And then we indeed decided to go more for embracing the material, with input from Liat, and I tried to structure it by giving it those structures, or essentially letter forms, are connected together. It comes from old stuff called grid fonts, but I cannot go into that now. But essentially now the results are quite nicer because less recognizable as a placenta image, which is not recognizable on its own already. So that's also a challenge, right? When you're doing portraits of faces, it's quite easy because of pareidolia, right? It's easy for us to recognize a face. When you start abstracting things that are already kind of abstract in nature, it's much more difficult, at least in my experience, especially when you're working with those AI systems. And because of that, I will give some technical background, not too technical, but as I said before, I'm obsessed with generating curves that kind of look a bit like they're hand-drawn, and I did my PhD here about the topic. And I kind of shied away from machine learning techniques for my whole PhD. And eventually I was thinking, okay, how can we use those modern vision systems as like very powerful, that give us objectives and image space, like similarity to image, have strong perceptual features, or can be controlled with prompts, and how can we combine that with those calligraphic-like strokes, right, that then we can execute with a robot. And the other reason that kind of got me into machine learning is the way in which modern machine learning pipelines are built, right? So you see a typical neural network, but the backpropagation algorithm that trains those neural networks actually nowadays is implemented with what's known as automatic differentiation, meaning that you have components that you can kind of plug in together. As long as you have a way of computing a rate of change of the system you're developing, you can plug it into this thing like Lego, right? And this leads to this thing called differentiable vector graphics, which relates to what he was talking about, Gaussian splatting, right? So all those new technologies that, let's say, you can do 3D reconstruction or vector graphics reconstruction rely on this principle, right? You plug in this object that you can propagate gradients through. And so during this project, one of the goals was how can we have those nice calligraphic curves with those systems. And so we ended up, part of the labor project became also a research project. We developed a whole paper that describes the system, so you actually can access the code and read the paper, which is open source online, which is kind of the basis for the technologies developed in EACVA at the Goldsmiths side, and also in collaboration with Constance. But essentially, this is the pipeline, and when you do those kind of papers, you go with more like friendly images, right? So here's like an example of an abstraction of a dog. So this is the kind of backbone of labor, and the actual flexibility of the system I showed you before is that I can say, okay, make those strokes similar to, I don't know, a silhouette, an image or something, but also in this kind of abstract space of those models that have been trained of loads and lots of images and develop really powerful perceptual features, make it, for instance, similar to an image, right? So that means that I don't need a drawing of Anna or Liat. I can give it an image of a drawing, and those systems can capture some elements that then we recognize. And then, plus that, we use this type of curve generation methods that generate curves that are compatible with a robot and aesthetically, also in a motion way, look nice. So this is one approach, and this is an example, practical example of an optimization, right? Images, I like using Spock in those examples. So Spock, music sheet, and then you've got a kind of musical Spock. And of course, it's not real time, right? So this takes, in my old computer, this would take, I don't know, 10 minutes. Now I have a better computer, it takes 1 minute, which is much better, so less nights waiting. And then this is an example of the robot generating it, because we generate, it's quite naive, right? So brush stroke is just, in this case, modeled as thickness varying along a stroke. So it's like a 3D stroke, kind of, 2.5D, but then you can let the system kind of figure out when to take the pen out automatically, right? Because when the stroke width becomes 0, you can interpret that as the brush getting lifted from the canvas. And this is a practical example of the labor we were looking before, right? So this is an example of the optimization we used in Berlin. In this case, we use a model known as CLIP, which is this thing that has basically a shared space between images and text. And actually, we ignore the text completely here. It's just that by training it on all those images, it develops those internal features that can guide image generation, but also vector graphics generation by plugging into the system this differentiable rasterization component. And another thing that came out of this, and it's what we used in the project with Anna, is instead of using splines, which are a common way to generate curves in computer graphics, we use this model of human writing motions that I was working on during my PhD, developed by a professor in Canada. And in this case, this actually explicitly models the kinematics of a hand motion, right? And it explicitly models the time of each stroke, sub-stroke that you're doing, right? And that means that while here we were like, the smoothness here is modeled, oops, I'll go back. The smoothness here is modeled as like, changes in acceleration, changes in acceleration. In this case, you can say smoothness is as fast as I move, the smoother the movement will be, right? So if I don't have to be precise, I can move fast, and I can make a smoother motion, and you explicitly model that, and that turns out to be useful in robotics because you can, well, this is our colleagues in Switzerland running the robot, and you will see that it can do this kind of more rapid motions. And with the Anna's project, we used that. If I remember correctly, I'm not 100% sure because there were a lot of tests involved. And yeah. So again, very demo images, right? It's a dog. And with Liat, so it's fun because it becomes this thing where you try to make it methodical, but then we kind of go crazy with Liat and mess with materials and things. And it's fun. And then the messing with materials actually informs the research. So it's a kind of feedback process that goes back and forth. A bit unorthodox way of doing research. That's less rapid. But again, this is kind of the brush technology, right, that we were using in these projects. And yes, this is an example of Anna's, so we can see the actual optimization running. These are different optimizers. It's kind of like shaky, but it converges much quicker. And yeah, so pick it up again.
Well, just conclude with the...
Yeah, okay, so we're going to show the video in EPI, which was the second iteration, which was shorter than Berlin, so smaller. And this is even smaller because it's shorter than Berlin and then EPI. And you can ask questions if you have them, right?
Mm-hmm. Yeah, thank you.
Thank you. Yeah, I'm the mic man. If there are questions.
Thanks, it's amazing work. Liat, could you say more about your conceptions of the agency of material? Like, how do you... Yeah, I guess, can you just say more about it? Because I thought that was really, really interesting.
Let me think. Like, the agency of material, like, it's a huge topic by itself, but I'm trying always to think where, like, when you work creatively, for me at least, it's always about conversation. I think there are many, many different artists out there, and some it's about the control, it's about like trying to execute an element, and for me it's about, I would say, more of a conversation. And I like to let myself to be surprised by the material that I'm using. And one of the things that I realized when I started working with robotics, like with Professor Duysen at 2016, was the fact that as I open up the conversation to other agencies, not as my own, it opened up more question about why I was doing things the way I was doing before. And it led me to realize that we are doctrinated in many ways through just our upbringings, from what we've seen, what we consume, and how much the medium define our visual language. So if you're a painter, if you're a draftsman, if you're a musician, like, I think it really depends what kind of a tool. If I'm working with a brush, I'm working with a pen, if I'm working with a pencil, it will define very differently the aesthetics and the decision making and the adaptation I would make through the process. And the freedom I received from me working with robotics, for example, was, okay, there was not really much predefined aesthetics for robotic painting. One can say there is already a robotic drawing or drawing machine and apparatus that have a very strong aesthetics, but for the painting element, I think we're still in a fairly open space where we can define and go to many directions. And I try to rethink from the beginning all the materials. So since then, I'm almost never buy paints. I try to make it, working with pigments, trying to understand, really decide exactly what is the paper, what is the brush I would like to use, why I would like to use it, and to always not to get frustrated if it doesn't do what I want. The same with the machine. but try to adapt myself to the result. And then to understand as well how I'm physically reacting to it. So I'm breaking down the physical process of painting. Like, it's not about trying to control what I'm seeing in order to achieve a certain image, but it's whether I've done a stroke here, which end my arm here. Now, what will be the next one? Would be like the physical to lift, go all the way, or to keep going in that direction, and that change with the materials I'm working. And I kind of liked as well this kind of an idea of like action scores that existed already thanks to the Fluxus movement in the 60s, like, or Solevi, for example, that you have an idea of like, constraints that you work within in order to clean the intention of what you're trying to actually express. So it's kind of with the less is more, like more intentional, more precise. So as you choose a robot, you choose a brush, and they will equally be important, despite the fact that a robot costs a couple of thousands and a brush not. But yeah, but
Thanks so much.
Fascinating talk, thank you. I have a very low-level question, but it's important, which is with the brush strokes, and I'm thinking particularly of the calligraphy brush. How does that work? Does the brush pick up a whole load of ink and then just paint for a long time, or does it have to keep picking up ink, or do you feed it ink?
If you come after the symposium, we're gonna give a demo. But
okay.
Essentially, I give it a distance, and when the sum of the brushstroke distance has reached a certain limit that I give it, it will go and lift.
Okay.
And in some cases, it kind of cleans the brush to like reduce excess, and in other cases, it just goes with a full brush. You will see it near the robot. There is a whole trajectory of brush drips, ink drips that come from me being lazy and not doing the thing.
But I can even like add to this, because like this is one approach that we are doing now. So it's a kind of a blind method.
Yeah,
so there is no visual feedback. There is no motion sensors.
Yeah, good point. Yeah.
So it's all kind of algorithmic processes that we set in place according to what is logical, to how we would kind of like, the level of control and level of lack of control, of randomness we want to give to the materiality. So for example, if you work with much more wet, then our control goes down. There is as well in the exhibition another work that I'm showing what I've done with Zurich. It was the first time that I was working with neuroinformatic department there and with neuromorphic processors. And this is it was a new realm for me, the biological inspired hardware, where we actually created a situation where the robot is painting on one side, and because of the nature of calligraphic paper is very, very thin, it's transparent, so we created a frame that holds this, you can just like screw it through all the time. And on the back side there was a DVS camera that just captured how the strokes is growing and changing. And we kind of mix it together with there was a sensor about just for the brush for the deformation to measure that, and there was the recording of the robot's movement. It was a very unprecise universal machine, the Euro 10, I think.
Precise, actually.
Yeah.
Very precise, much more precise than ours.
Okay. But the kind of the idea was to try exactly to do that. Like the beginning of this entire work was I'm doing a brush stroke. And then the machine needs to try to recreate it, and every time it needs to recreate the last stroke that he's done, which is for a human a very hard task to do. I think I will encourage everyone here to just try to do that and see how it feels and what kind of part of our brain and our body start to be operating. And to even like deal with question of like overlapping stroke that for computer vision is like a big no-no, but because of that's what I know at least, but because of the DVS camera going together with the information of the robot access and so on, we can kind of try to track it and to find this information. But I think this like how to operate a calligraphic brush, it's by itself or just a normal brush, a huge research for, I would say even for us, from even psychology perspective, I would say. But
What made it even more hilarious is that they had the bug in the sensor, right? So they had to keep it in the fridge.
no, it was not the sensor, but the processor.
Yeah.
So the neuromorphic processor do not exist in commercial, you cannot buy them. And we had one that Professor Giacomo Indiveri built that belongs to the ETH. And those hardwares are very, very sensitive to temperature. So when it was cold, it misbehaved, and we done the exhibition during the Zurich Art Weekend, and it was very, very hot. So we needed to always bring ice pack from the fridge and to put like a fan on it just so it will behave. So that was kind of as well the embodied of the machine.
Thank you.
Just picking up on what you just said there about lack of visual feedback for the robots, do you think that that is an impediment to making more sort of accurate, realistic robot kind of art?
I mean, it certainly can help, but I mean, also Michael can talk a lot about that probably, but I think in a live setting, and Patrick probably knows even more about that, but in a live setting it has challenges, right? Because live setting, something might work in the lab, then you go in a different lighting condition, things change, and that can be more challenging, right? So currently our system here, we have a system for basic visual feedback in our robot here, but here is like completely like feed forward, right? So it's like, if I remove the paint jar, we do it actually sometimes when it's dipping too much, Liat will just remove the paint jar and the robot will go like
in the air.
like just dip in there, yeah?
But I would ask you this question too. Like what happened when you paint blindly and what happened when you paint...
Exactly.
And this is like the
as
question
a real
of...
artist, you could hardly imagine working with a blindfold on. Yeah.
But that's the question...
Like certain things depends.
I think it depends of many questions that we need to kind of understand how our brain works and what, like where we see, what we see, how we see, and when we give vision to a machine, what is the goal of this vision? And after we can answer that question, we need to think, is it necessary? Specifically for labor, we didn't find vision needed. Like our eyes were there to do the adjustment.
I think that that vision, let's say in graffiti, for instance, like vision comes in at a very low frequency, right? So a lot of the things are like automatized, like movements that I could do to you without looking. But if I have to compose them together, there is where vision comes into play, right? So how do I put those two things together? But continuous vision during the stroke making would influence the spontaneity, in my opinion, of the stroke. But then again, those are things that are not super clear. But yeah.
One there and then one here.
Sorry. Yeah, thanks. It's a really amazing project. I really love what the output looked like. I just would have thought, like, if you knew nothing about the project and you were walking past and saw what you guys are doing, it almost looks like you guys work for the robot. Because, you know, you're doing all the prep work and then, you know, getting everything ready, then it does the fun part, and then you varnish it and hang it up. Like, how do you feel about that conceptually as artists, and did you think about that as part of the project?
It's unfortunate, it's true. I have nothing else to say to it. It was like the robot ended up doing the creative fun stuff and we are doing all the labor behind it.
And then there is like months of programming behind it.
Yeah. Was that something you thought about as part of it, or did that kind of just come out of the process? Or what's your
It was part of that because it was important for me to show where is the, like, first of all, there is a lot of like the knowledge of exactly the strokes and so on that the robot is still not doing very precisely or the way we would like it to do. But it was important as well to show like how the banal element that no one think of, that are usually like behind the scene, actually involved human intelligence. Like in what we've done there, it's not something that any person from the street can come and do this like laborious work. Even just, you know, putting the imprimatur of the paint in the background, it's like something that only Danny and I had the knowledge of exactly the tone and the aesthetics and so on. So it's exactly that, is to give again the stage to what it seems to be unimportant. It's like another question here in the front.
Hi, really good work. I'm not sure if this is a question, but it reminds me what really captures my attention is seeing the robot drawing. It's the action itself, and I'm reminded of a documentary by Clouseau of Picasso's painting, from the back, exactly as you were saying. So we don't see his, we only see the result, but from the back, and it's. Could we be able to teach a robot Picasso's method and just replicate exactly the same way as Picasso's
I can say to
traits?
it maybe like a yes and a no. If you take a style and you want to try to replicate a style and you reduce it into a very clear set of actions and result, then yes, you can create, like you have people who create copies of. This is basically what they're doing. They're learning a style and then they're like, tuck, tuck, tuck. And then you have those who do a very good copy that's hard to distinguish. And then you have those like really cheap copies that you go very quickly, okay, this is some cheap copy of Van Gogh or Picasso or whatever. And I think a robot can achieve the very dumb copy if you break it down into those very clear methods. But the creative process, I think what makes the Picasso to be the important of Picasso, it's the thought that were behind to come into those set of actions. And this is like,
Also the history of motions that he did.
Exactly.
Lifetime.
His entire, and this is something that is,
That's why I'm asking, can we teach a robot?
we can teach a robot to copy, but not, to, I think, to be genuinely, like to my opinion at least, because he doesn't have, I would say, even the physical memory that Picasso had from all the painting he had before that goes together with his daily experience and the sensation that he has as a human that flowed into it.
My question was about the stop motion, seeing it. You could go ad infinitum watching a robot
Painting. It's fun.
paint
Yeah.
instead of seeing the final result. But
Yeah, the process is
the process,
important.
and that's
Yeah.
why also the film is so fascinating because you see the process.
It's a different process. This is more uncanny, I guess, because it's a robot and it's very different.
Yeah, it had, I think, its own magic to it, but I think I would like you as well maybe to refer to Kentridge with his like drawing sessions and so on, because he's keep showing off like, the drawing itself are not relevant. It's about the thought. He's doing a line and erasing and doing it again and changing it and rethinking it. And this is what we kind of try to open up here with this mechanical operation that usually seems to be something that's very deterministic and something that goes with a product in the end. And we try to show an adaptive method of how human and machine can collaborate in something that we think can have a conversation with the materials, with the machine, and us with each other.
And arguments.
Let's have part of that. Okay.
Just am I on? I don't know. Can you hear
How are
me?
we time?
Yeah, just a quick one to follow up on a kind of all these questions, because I'm quite liking this idea that's coming up between, you're saying the intention behind the art and then the robot is carrying out the process because it's completely feed forward, I think you were saying in this. And what you kind of think about that as a collaborative aspect, because I like this idea of, so the body is the embodied, the robot is the embodied part of the process, but you're the kind of the intention behind it. And do you view it as kind of a collaboration? I suppose you say conversation, but I just like this idea. I don't know what your thoughts are on
With each other or with the robot?
with the robot. I guess with the robot. Sorry, you two and the robot. Yeah.
I can say what I think.
For me, the robot is a tool.
Yeah.
It's a tool that you converse with, the same that I would converse with a brush, but the level of control that I have is much lower. And I have as well Danny as part of, like, it's exactly, but this is part of it's not the tool, but it's part of the conversation. That you said, I never said that. But this is another level of conversation. Like I hard to see, like for me, the robot is not an embodied creation by itself or embodied like entity. It's a tool. We are the embodied element that try to reflect of our embodiment and our knowledge in that, and to find how new technology can have a body. Because for me, at least, I have this feeling that there is so much an obsession about the image, and how an image come to life as an embodied process was being erased.
Yeah, it's like a programmable arm. which is what it is, right?
Yeah.
So you can program it to do interact with the environment, and you can have control over it by programming it, which is interested in its own as a process, right? But again, it's a tool. It's kind of a tool.
Yeah, I guess that's what I mean.
That's how I see it too. Yeah, but it's a matter of you can give it agency easily because it's easy to see. You remember the story I told you about the many people in Berlin. I think it's still programmed in. There's like a pause. It dips.
Yeah.
And then there is a pause in the code just for security to me to check everything. And I forgot to remove it and I left it. And the robot pauses for maybe a second or half a second before starting to draw after dipping. And people see it as the robot thinking what it's going to do.
Yeah.
But it's actually time sleep 1 second. Yeah.
Yeah. It's interesting. The tool it does fall into that as well. From a psychology perspective, in some embodiment research, people feel as if the tool is an extension of their own arm, so a brush, and even implicitly it's been shown that people act as if it's kind of still part of their arm. So interesting.
But this is the new level of agency that we have, I think, with the advance of technology today, that you give it its own agency. It's not anymore an extension of your body, but you give it element that comes from your body. And I think this is something that relates very good to the early talks that we had today. The talks about the embodiment of the machine itself, like, how imprecise or precise it will be depends on just the mechanical structure of it. And the mechanical by itself has a logic that is very different than, I would say, just the digital simulation world that we live in. And what we are trying, I think, to do in this is to find this merging point of how can you take this digital knowledge but give it a mechanical body. And to go then with the biological body of us as humans and to open this conversation.
Thank you.
Okay, one last, or we have time, or we are...
If there's a last one,
Last one.
Thank you. This is a very specific one. In one of the images, the background was all green and you had the strokes and you layered the strokes that were offset just a few centimeters to the right and it was a bit brighter and created this beautiful sort of depth effect and a little bit of glow. It's very expressive. So I was just wondering, because you two are very good at analyzing and breaking down the process and then structuring it into instructions for the machine. There's a whole wealth of algorithms out there. How do you kind of like filter through the noise, and what's your decision system like to go from what all the options are to the options that are best that get you those expressive results?
I would say...
In my case, it kind of came naturally because we had this project and I have this obsession of working with strokes, right? So the project became me exploring differentiable rasterization as a tool, and that became the main tool for labor, right? So it's kind of like, okay, I'm working on some research at the university, and we have the project, artistic project with Liat, and I'm throwing that into, so it's kind of, how to say, at the moment, right? It's kind of fits together. It fits together also because with Liat we have overlapping interests, right?
So it
just works. Yeah.
It's based on basically our own experience, coming from both art and science, asking exactly those questions and finding the solutions that aesthetically please us and being functional enough to operate from robotic operations.
So I mean, there's always, and again, nowadays, especially with machine learning, there's more and more choices, and it's crazy. It's just like, it's very hard, becomes hard to choose, and so lengthy to wait for the choice. Yeah.
Okay. Thank you.
Thank you.